I'm going to explain what multiples, LCM, factors, HCF, and prime numbers are in that order. Let's begin with multiples. The multiple of a number is that number multiplied by some whole number. So let's take 8 as an example and list the first few multiples of 8. Let's take the first multiple of 8. The first multiple of 8 is 8 multiplied by 1, or 8 itself. The second multiple of 8 is 8 multiplied by 2. The third multiple of 8 is 8 multiplied by 3. And I'm sure you've got the idea, so I'll list a few more. Now, I've put etc. because they do go on forever. I could keep, in effect, adding 8 to get the next multiple and the next multiple. But actually, the quicker way to work out the multiples of any number is to multiply the given number by whatever the multiple we want. So, for example, the 10th multiple of 8 would be 8 multiplied by 10, or 80. The 11th multiple of 8 would be 8 multiplied by 11, or 88. The 100th multiple of 8 would be 8 multiplied by 100, or 800. Now, getting a little more creative, we could say that the 101st multiple of 8 would be 8 multiplied by 101, which the easy way is to say, well, the 100th multiple of 8 was 800, so the 101st multiple will be 808. Likewise, the 99th multiple of 8 would be the 100th multiple of 8, which is 800, subtract 8, so 792, and so on. Let's take another number. Let's take the number 12. Again, the first multiple is going to be 12 times 1. The second, 12 times 2, and so on. Again, I've listed the first few because, again, the multiples of any number can go on forever. But another important point to note is that the first multiple of any number will be that number itself by definition, because the first multiple is that number multiplied by 1, which always gives you the number that you were given. Now, let's look at the idea of lowest common multiple. Lowest common multiple is self-explanatory, meaning that the words that make up the phrase explain the meaning of the phrase. Well, first of all, multiple, we know what a multiple is. Common in this context means shared, and lowest means the smallest number. So it's the smallest number that is a multiple and is shared. So if we look at 8, we're looking for a common multiple, i.e. a multiple that they both have. Well, let me identify any common multiples that I can find of 8 and 12. Looking at the list, they both contain 24, so that is 24 is a common multiple. Going further, they both also contain 48, and if I continued my list, we would find other common multiples of 8 and 12. So we've identified two common multiples, them being 24 and 48. Now, we're supposed to find the lowest common multiple. So that means the smallest number that is a multiple of both. Well, I'm sure you can see that that's 24. So 24 is the lowest common multiple of 8 and 12. So let's move on to factors. The factors of 8 are the numbers that go into 8. Now, a tip for working out the factors of any number is to start with 1. Now, 1 will divide into every whole number, which means that 1 will always be the smallest factor of any given number. Then you try 2. Does 2 go into 8? Yes, because 8 is an even number, 2 will go into it. Then you try 3. Does 3 go into 8? No, it does not. So we leave it out. It is not a factor of 8. Does 4 go into 8? Yes, it does. Now, we've reached the halfway point. meaning we've got half of 8. Now, there's no point trying 5, 6, or 7. Because they're more than half of the given number, they definitely won't divide exactly into 8. So I know that the next factor of 8 is going to be 8. So in other words, the factors of 8 are 1, 2, 4, and 8. Those are all the numbers that will divide exactly into 8 without leaving any remainder. So there's a big difference here between the idea of multiples and factors, is that the multiples go on indefinitely, meaning there's no limit to how many multiples there are, whereas with factors there's always a limit. How many numbers will go exactly into 8? Well, the list is short, just 4. Let's do the same now with 12. The factors of 12. 1 goes, 2 goes, 3 goes, 4 goes, 5 doesn't, 6 goes. Now 6 is halfway to 12, so anything bigger than 6 cannot go into 12. So I won't bother trying 7, 8, 9, 10, and 11, and of course 12 goes into itself once. Now, one point to make here is that the list of factors of any number will always begin with 1 and end with the number itself. And then there'll be other numbers in between. And the method that I've demonstrated here is to start with 1 and increase to 2, then 3, then 4, then 5, without missing any. So you try all of them, and obviously you only list the ones that actually will go. Now we'll come back to factors of larger numbers in a while. But we can use these to explain what HCF means. Now again, the words themselves explain the meaning of this. Obviously the F means factors, C means common, and H, you will have guessed, means highest. We know what factors are. We know what common means in this context. It means shared, and highest means the biggest number. So we're looking for common factors. So we look at the list of factors and see, well, which factors are common? 1 is common, 2 is common, meaning shared, 3 is not common, 4 is common, 6 is not, 8 is not, and 12 is not. So 1, 2, and 4 are common factors of 8 and 12. But we want the highest common factor, so meaning the biggest number, which is a factor of both. And obviously it's 4. So there we are. 4 is the highest common factor of 8 and 12. Now let's come to prime numbers. There's a little confusion sometimes with prime numbers, but it's very easy to clear up. A prime number is a number that has exactly 2 factors. No more than 2, no fewer than 2. Now, if we take 8, clearly it is not a prime number because it has 4 factors, and a prime number must have exactly 2 factors. 12 is clearly not a prime number because it has 6 factors. Let's take the number 3 and look at the factors of 3, because prime numbers is all about factors. What are the factors of 3? Remember, we always start with 1. 1 obviously goes. 2 doesn't because it's an odd number. 3 does. And that's the complete list of factors of 3, just 1 and 3. Nothing else will go exactly into 3. So 3 has 2 factors. That makes it a prime number. Let's take another one. Let's take 4 and list the factors of 4. 1 goes, obviously. And remember, every list of factors begins with 1. 2 goes because 4 is an even number. 3 does not go. We shouldn't even bother trying it because once we're halfway to the number, the next factor will be the number itself, and 4. Now, because 4 has 3 factors, it is not a prime number. Let's try 5. 1 goes, 2 doesn't, 3 doesn't, 4 doesn't, and 5 does. Since 5 has 2 factors, it is a prime number. Now let's skip a few and try 9. Let's test it to see whether it is a prime number. 1 goes, 2 doesn't, 3 does, 4, 5 don't. Now since we're past halfway, the only remaining factor will be 9 itself. 9 has 3 factors and therefore it is not a prime number. Now the one that children and adults for that matter get confused about is 1 itself. Is 1 a prime number or not? Well, let's test it in exactly the same way. You don't break the rules. The rule is that it is a prime number if it has exactly 2 factors. So what divides exactly into 1? Well, 1 does. Does 2? No. Obviously 2 is bigger than 1, so it won't go exactly. So that is a very short list. 1 has only 1 factor, and therefore it is not a prime number. So just to emphasize the point, those that have 2 factors exactly are prime numbers. So 3 is prime. 5 is prime because it too has only 2 factors. And 4 is not prime because it has 3 factors. 9 is not prime because it has more than 2 factors. And 1 is not prime because it has only 1 factor. I want to demonstrate a technique which is very useful for listing the factors of a number that has a lot of factors. Well, these had only a few. But if we take a number like, for example, 180, that has a lot of factors. And I'm going to demonstrate a good technique for listing all the factors of 180 in a quick and systematic way. This is the way I recommend. Let's take 180. That's our given number, and we want to list all the factors of 180. Now, the best way to do it is in size order. That way you know you haven't missed any. When it has only a few factors like these numbers, it's easy to know and easy to check that you have all of them. But when you have a big number with a lot of factors, it's not so easy. You might miss a few. So you start with 1 and you ask, well, yes, 1 goes into 180, but how many times? It goes 180 times. So you'll notice I've written them as a pair, one above the other. So in other words, we're writing 2 factors at a time, the smallest and the largest being the first pair. Then you try 2 and you say, well, does 2 go? Of course it does, because 180 is an even number. And how many times? Well, you say 180 divided by 2. Well, that's going to be 90 times. Then we try 3. Does 3 go? Yes, it does. 3 goes 60 times. Now what we're doing is we're building up our list twice as fast as doing 1 factor at a time. We're doing them in pairs. Does 4 go? Now here is a little trick that will help you. If 2 goes 90 times, then 4 will go half as many times. Because 4 is twice as big as 2, it will fit half as many times. So since 2 goes 90 times into 180, 4 will go half as many times, or 45 times. 5, yes, because it's a multiple of 10, of course it's also a multiple of 5. So 5 will go. Now, the easy way to work out how many times 5 will go is to say, well, 180 is 18 tens. Well, every 10 is 2 5s. So if it's 18 tens, it's twice as many 5s. In other words, 36 5s. So 5 goes 36 times. Now, we come to 6, and it does go, but what's this trick? Since 3 goes 60 times, and 6 is twice as big as 3, we'll be able to fit half as many 6s into there. So 3 goes 60 times into 180, so 6 will only go 30 times. 7 doesn't go. An easy way to check that is to say, well, 7 times by 10 is 70. Double that is 140, and that leaves a gap of 40, and 7 won't fit exactly into that gap. So 7 is eliminated. 8, well, 4 goes 45 times, so 8 will go half as many times, which would be 22.5, which is not a whole number. That means 8 does not fit exactly into 180. Does 9? Well, 9 goes into 18 twice, so into 180 20 times. And 10 obviously goes, because 180 is a multiple of 10. So 10 will go 18 times. Then we try 11. It doesn't go, but to check, you could say 11 times 10 is 110. That leaves us 70, and we know that 70 is not a multiple of 11, so that's out. Then we try 12. Well, 6 goes 30, so 12, being twice as big, will go half as many times. So 6 goes 30 times, so 12 will go only 15 times. So 12 will go 15 times. Then we try 13. Now 13 doesn't go, and the way I would check is this. I'd say 13 times 10 is 130. That leaves me a gap of 50 to make up to 180, and I know 13 does not go exactly into 50 because 4 13s are 52. So 13 does not go. 14. Well, 7 multiplied by 2 makes 14. 7 did not go, so 2 7s will not go. So if 7 did not fit, then no multiple of 7 can fit. So I know not to bother with 14. And then the next one would be 15, which I've already listed. So because I've already listed, I know now that I have the complete list of the factors of 180, and they are in size order: 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 20, 30, 36, 45, 60, 90, 180. So starting from the smallest and going to the biggest, I have the full list. So if you do have to list the factors of a number which has a lot of factors, this is the recommended technique.